Aloha, my name is Rick Dyer. I'm the Safety Manager for Partners in Development Foundation here in Hawaii. Today we're going to discuss a little about electrical safety. There are volumes written on the subject, and we're just going to scratch the surface, but hopefully you'll have enough information by the time we're through to be able to work safely around electricity in the workplace and at home. All right, so let's get started. We're surrounded by electricity every day, and it behooves each of us to learn the hazards involved with it. Do you use a paper shredder? How about a copy machine, a microwave oven, a power strip, or a landline telephone? Well, if we're not careful, these things that we depend upon to make our lives so much easier could be the death of us. Watch this 7.5-minute video on living safely with electricity. Electrical safety for non-electrical workers. Assume that all overhead wires are energized at lethal voltages. Never assume that a wire is safe to touch, even if it's down or appears to be insulated. Never touch a fallen overhead power line. Call the electrical utility company to report fallen electrical lines. Stay at least 10 feet, 3 meters, away from overhead wires during cleanup and other activities. If working at heights or handling long objects, that includes the ladder in your hands, survey the area before starting work for the presence of overhead wires. Never operate electrical equipment while you're standing in water. Never repair electrical cords or equipment unless qualified and authorized. Have a qualified electrician inspect electrical equipment that has gotten wet before energizing it. If working in damp locations, inspect electric cords and equipment to ensure they are in good condition and free of defects, and use a ground fault circuit interrupter. Always use caution when working near electricity. If an overhead wire falls across your vehicle while driving, stay inside. If your vehicle comes into contact with a power line, if it's still operational, back out and away from the power line. If your vehicle is not operational, do not get out of your vehicle. Call 911 and your local utility service for help. Wait for the electric utility company representative to come, and they will tell you when it is safe to get out of your vehicle. Never try to rescue another person if you're not trained to do so. If you absolutely must leave the vehicle, if it catches on fire, exit by jumping as far as possible, at least 2 feet. Never touch the vehicle or equipment and the ground at the same time. The way you should get out of your car is open the car door, put both feet on the edge of the step, put your hands together, do not touch the car door or the hood or any part of the car, and jump with both feet together, landing with both feet touching each other about 2 feet or as far as you can safely away from the car on the ground. Look for a flat place on the ground to land. Then continue hopping with your arms close to your body and your feet always touching each other away from the vehicle. If you're unable to hop, shuffle your feet, but always keep your feet touching. The reason to keep your feet touching and not let them separate is if there's a voltage difference between the location of one foot and the location of the other foot, you could sustain a shock. When you are at least 10 yards away from your vehicle, slowly slide one foot away from the other. If you start to feel a slight tingle, slide your feet back together and resume hopping or shuffling away from the power line. Another caution, unrelated, do not enter an electrical power substation or other marked areas. Watch this following short video of a Kalihi fire that was caused by downed power lines. You are responsible for your own safety and safety of others. The voltage of the electricity and the available electrical current in regular businesses and homes has enough power to cause death by electrocution. Even changing a light bulb without unplugging the lamp can be hazardous because coming in contact with the hot, energized part of the socket has enough voltage to kill a person. Even low voltage carries hazards. A shock can contribute to a fall. A low voltage arc flash has the same potential to ignite explosive materials as 120 volts. What I mean by low voltage is communication equipment, coax cable, that kind of stuff. All electrical systems are dangerous. Electric current consists of electrons that pass through a conductor. A conductor is a material that allows the movement of electricity through it. Most metals are in fact conductors. The human body is also a conductor. Dry wood, glass, and plastic are not good conductors. Burn, shock, electrocution by death, fatality caused by falls, these are some of the injuries that could result from electric current being passed through your body. Some basic general tips. Make sure that exposed receptacle boxes are made of non-conductive materials. Know where the panel and circuit breakers are located in case of emergency. Label all circuit breakers and fuse boxes clearly. Each switch should be positively identified as to which outlet or appliance it is for. Do not use outlets or cords that have exposed wiring, or if the cord looks damaged and could contain broken wires. Do not use portable cord and plug connected power tools with the guards removed. Do not block access to panels and circuit breakers or fuse boxes. In fact, OSHA mandates a 36-inch minimum clearance. Be cautious of arc flash when flipping breakers off and on. Do not touch a person or electrical apparatus in the event of an electrical accident. Always disconnect the power source first. On the right is a thermal imaging image. Notice the area around the wires and the switch are warmed by the current. The numbers indicate the temperature. What we can't see can kill. Grounding and ungrounded equipment. Grounding is a method of protecting users of electrical equipment from electric shock. Grounding an electrical system intentionally creates a low resistance path to earth through a ground connection. When properly created, this path offers sufficient low resistance and has sufficient current carrying capacity to prevent the buildup of hazardous voltages. Most fixed equipment, like large stationary machines, must be grounded. Equipment connected to electricity by cord and plug absolutely must be grounded. If 1, located in hazardous or wet locations, 2, if it's operated at more than 150 volts to ground, or 3, if a certain type of equipment such as refrigerators and air conditioners. In any case, never remove the third grounding prong from any 3-prong piece of equipment. Avoid not having enough outlets or overloading the electrical outlets that are available. A sufficient number of outlets will eliminate the need for extension cords. Overloading electrical circuits and extension cords can result in a fire. Floor-mounted outlets should be carefully placed to prevent tripping hazards. The use of poorly maintained or unsafe, poor quality, non-approved by National Testing Laboratory, coffee makers, radios, lamps, space heaters, etc., often provided by or used by employees, should be discarded. Such appliances can develop electrical shorts, creating fire and or shock hazards. Equipment and cords should be inspected regularly, and a qualified individual should make the repairs. When the outer jacket of a cord is damaged, the cord may no longer be water resistant and the insulation can absorb moisture, which may then result in a short circuit or excessive current leakage to ground. If wires are exposed, they may cause a shock to a worker who contacts them. These cords should be destroyed and replaced. Electric cords should be examined on a routine basis for fraying and exposed wiring. In case you're tempted to go to Home Depot and purchase a new cord end and put that on a damaged cord, by just cut off the bad part and replace the cord end, that's not appropriate by OSHA standards because you're not replacing it to the manufacturer's original condition. A cord should not be pulled or dragged over nails, hooks, or other sharp objects that may cause cuts in the insulation. In addition, cords should never be placed on radiators, steam pipes, walls, or windows, or under carpets, rugs, or furniture. Particular attention should be placed on connections behind furniture, since files and bookcases may be pushed tightly against electric outlets and severely bend the cord at the plug. This breaks the wires inside the plug and can cause shorts and arcing. Take care not to roll over cords with office chairs. An adequate number of electrical outlets should be provided. Extension cords should only be used in situations where fixed wiring is not feasible. However, if it is necessary to use an extension cord, avoid running it across walkways where it poses a potential tripping hazard. If it is unavoidable to run a cord across a walkway, either tape it down with duct tape or purchase a cord runner, or better yet, elevate it above the walkway. Wall receptacles should be designed and installed so that no current-carrying parts will be exposed. And outlet plates should be maintained to eliminate the possibility of shock. Watch for burn marks on wall plates. Have an authorized electrician inspect the outlet and replace it if necessary. Also replace broken wall plates. On-off switches should be provided either on the equipment or on the cords to avoid having to pull the plug to shut off the power. Never pull a plug out by the cord. To remove a plug from an outlet, take a firm grip on and pull the plug itself. Disconnect electrical machines before cleaning, adjusting, or applying flammable solutions. If a guard is removed to clean or repair parts, replace it before testing the equipment and returning the machine to service. Utilize proper lockout-tagout protocol. If an electrical malfunction should occur, the panel door and anything else in front of the door will become very hot. Electrical panel doors should always be kept closed to prevent electrical flashover in the event of an electrical malfunction. If it doesn't look safe, it probably isn't. Take a moment to examine this image of a daisy chain. 2 power strips plugged into one another. Even if it does look safe, it may not be. Many of us are accustomed to stacking power strips or plugging extension cords into another extension cord because one might not be long enough. And it may not look like a problem, but it can become one. Do not use light-duty extension cords in a non-residential situation. Do not carry or lift up electrical equipment or tools or a tool bucket by the power cord. Keep power cords clear of tools during use. Suspend extension cords temporarily during use over aisles or work areas to eliminate tripping hazards. Replace open front plugs with dead front plugs. Dead front plugs are sealed and present less danger of shock or short circuit. You can examine that image there, the picture, to see what a dead front plug looks like and an open front plug. In fact, open front plugs it's illegal to manufacture them anymore in the United States. So it would typically be on older extension cords or older power tools or equipment. Do not tie cords in tight knots. Knots can cause short circuits and shocks. Loop the cords or use a twist lock plug. A twist lock plug is the kind that you push in and you turn it and then it locks into its opposite end. Do not place cords in water or wet areas. And check cord if frayed or damaged before use. A Class A ground fault circuit interrupter, GFCI, works by detecting any loss of electrical current in a circuit. It will trip at a maximum of 6 milliamps. Per NEC 210.8, the National Electrical Code, you must install GFCI protection for all 15 amp and 20 amp 125 volt receptacles located in bathrooms, rooftops, and kitchens in commercial industrial facilities. Every receptacle installed in kitchens must be GFCI protected. NEC 210.8b3 requires that all 15 amp and 20 amp 125 volt receptacles in a commercial kitchen to be GFCI protected. When a loss is detected, the GFCI turns the electricity off before severe injuries or electrocution can occur. Painful, non-fatal shock may occur during the time that it takes for the GFCI to cut off the electricity. So it's important to use the GFCI as an extra protective measure rather than a replacement for safe work practices. Portable inline plug-in GFCIs can be plugged into wall outlets where appliances will be used. Inspect cords and plugs. Check extension cords and plugs daily. Do not use and discard if worn or damaged. Have any extension cord that feels more than comfortably warm checked by an electrician. Do not plug several items into one outlet. Pull the plug, not the cord. Do not disconnect power supply by pulling or jerking the cord from the outlet. Pulling the cord causes wear and may cause a shock. Replace broken three-prong plugs and make sure the third prong is properly grounded. Use extension cords only to temporarily supply power to an area that does not have a power outlet, and only for 90 days or less. Keep extension cords away from heat, water, and oil. They can damage the insulation and cause a shock. Do not allow vehicles, machinery, carts, or wheeled chairs to pass over unprotected extension cords. Extension cords should be put in protective wireways, conduit, pipe, or protected by placing planks alongside them. I hope you have enjoyed and learned something from our little presentation on basic electrical safety. You may now proceed, if you're a PIDF employee, proceed to the intranet where you can take the quiz. Thank you. Aloha and have a great day. Be safe and see you on the other side.